Welcome to the Internet of Things Platforms video, second part, the advances in wireless connection. There are four main issues you need to know about wireless connection. First, if we take a look at current available wireless communication technologies, Wi-Fi is probably the most widespread. However, its short range means it is not always the best solution for outdoor gardens. Second, we continue using Arduino as the core boards in our project. So we should discover additional hats or shields which give us the new communication functionality we need. Using alternatives to Wi-Fi forces us to make a decision. It means we should decide between using the alternative solution only inside our school network or using it fully in the long distance between the sensors and the cloud. If you choose to maintain Wi-Fi technology as an access point to the Internet, we discuss about gateways as a bridge between different technologies. However, hats and shields selection depends on our Arduino board. More precisely, it depends on the architecture of our microcontroller. We review Arduino developments before summarizing this work. A communication technology involves different aspects. First, the set of issues which describe the properties of a signal and how a sender and a receiver are able to understand the information contained in this signal is the physical layer. The access layer is a bit more complex. It includes protocols and formats to manage and encapsulate the information. Additionally, components that form the network topology or other aspects such as security, reliability, or safety are also considered in the communication technology. So, wireless technologies are not without complexity. However, we limit our review to the aspects that you need to consider in a simple school practice. We are in the 21st century and technology is advancing very quickly, especially wireless technology. There are many solutions, but we need something robust and probably inexpensive as well. If you already have an available Wi-Fi network in your garden to connect with, use it. Otherwise, you have two options. Either connect each Arduino to the Internet directly, through a telephone operator, for example, or make a local network and use a gateway to connect your local network with the Internet. In the case of the latter option, we look for a long-range solution to connect our devices, or nodes, outside the school building to the Internet through our school network. Imagine that the solution has to cover from 1 kilometer to several kilometers. Moreover, we need some simple and robust plugin for our Arduino boards. So, each space has one or several nodes. A node reads information from the sensors and connects with a gateway, not directly to the Internet. The Internet connection is made through this gateway. Thus, the nodes and the gateway form our local network. The communication technology of this local network doesn't necessarily have to be Wi-Fi. Other solutions achieve better ranges with low power consumption. Therefore, you can build your nodes by adding a hat or a shield to a simple Arduino board. However, it is the best to maintain access to the Arduino pins. And what about the gateway? It could be a router that just receives the frames from your local nodes and forwards them as received to the cloud. Or it could be a bridge that receives the frames, adapts them, and resends this adapted or transformed information. So, you could develop your own homemade bridges by using Arduino boards too. However, hats and shields bring up a new key issue: the compatibility between the board and the hat or the shield. in both microcontroller and communication transceiver, and with the pins sketched. For example, Arduino has 3 main architectures, and Arduino Nano and Arduino 33 IoT have different architectures that are not always compatible with the same hats or shields. In summary, your school Wi-Fi network, if you have one, wouldn't always be available in open spaces. We recommend you to explore alternatives in communication technologies with wide ranges and low power consumption. Use available hats and shields compatible with your boards. Look for robust and easily pluggable solutions, although you will probably have to program code for your new gateways. To learn more, remember you still have one practice exercise, part 3, named Advances in Wireless Connection. The learning objectives we expect you to achieve with this practical exercise are to be comfortable with hats and shields that add functionalities to your original boards, be aware of compatibility issues, and get more practice in communication skills. Thank you very much for your attention.